All right, this is a tessellation. It's not important that you know what a tessellation is. It's just when you take one shape and move it around. Sometimes you flip it or rotate it. Doesn't matter. But this part of the page is for 8th grade. And so it just may be helpful for you to see. In Chapter 11, we learned that if one figure can be carried on to another by a series of rigid motions and dilations, then the two figures are similar. In the picture above, triangle 1 is similar to triangle 2. Describe the sequence of transformations that will carry triangle 1 onto triangle 2. And what is the scale factor? Well, a dilation would work. You could do one dilation depending on where the center of dilation is, but that's not completely crucial. I think if we use that as the center of dilation, we would do it in one transformation. However, most people would say that it's a translation and then a dilation, which would work as well. The scale factor from 1 to 2, though, is 2, because we can see that this side length, it takes 2 of those to get this side length. So triangle 2 is twice as big. That's the scale factor. And that's something you guys can do in 7th grade. On the other hand, we have triangle 2, which has been changed into triangle 3. So when we look at this, we have to see that we have this green angle here and this one. So clearly there's some type of rotation or reflection that's taken place. So some of you may say reflection and then reflection and a dilation. Others of you would say a rotation and then a dilation, and maybe even a translation's in there somewhere. But for the scale factor, though, we can see that triangle 3 is half as big. In terms of area, it's a fourth. So clearly the scale factor would be 1/2. So below is another fact about similar triangles. Given two triangles, if the corresponding angles have the same measure, then the triangles are similar. So if two triangles have corresponding angles that are the same, then one triangle can be mapped onto the other using transformations. Therefore, the triangles are similar. And do all three pairs of corresponding angles have to be congruent in order to say that the two triangles are similar? Yes. For triangles specifically, yep. If only two pairs of corresponding angles are congruent, they're still similar because it causes that third pair of angles, corresponding angles, to be congruent as well. So they would also be similar. So in terms of similarity, if we find that two of the angles are congruent, then we know that that third angle is also congruent. Therefore, the two triangles are similar. So these two are similar because we have the two 114-degree angles and the two 29-degree angles. So automatically, this third one would be congruent as well. Well, what about these two? On the surface, these two look like they are not similar because we do have the 66 degrees, but these two appear to be different. And they are different. The problem is if we solve for the missing angles, this one's 64 degrees, this one is 50 degrees, so as it turns out, they are similar. So now that we know that, we're going to have to use the same type of strategy to solve these ones to see if they're similar or not. So we just got to solve for the missing angles. Now they are close, but they are not exactly the same. 53 and 56 are different, and 34 and 37 are different. Therefore, these two triangles are not similar. They do have one angle that's the same, but the other two are not. So here we do have three triangles, and we just got to figure out if there are any two triangles that are similar. So take a moment, think about that. You may want to solve for some of the missing angles here. Alright, so let's look at some of these missing angles. Alright, so there are missing angles, and on the surface you're going to say that there's not any two triangles that are similar, but there is. Let's look first at this triangle here. This one we've got 20, 65, 95. And there we have that one. But there's another triangle that does have the same measurements. Let's go and take a look at that one. And there it is. Now again, if some of you see, if we get rid of that line, we see we have those two angles, and what do they add up to? 95 degrees. So that corresponds with this angle. The two 20-degree angles correspond, and the two 65-degree angles also correspond with each other. Therefore, these two triangles are similar. All right, take a moment and figure this one out. This one clearly has two similar triangles because we have these two vertical angles which are congruent. And since we already have these 42-degree angles which are congruent, automatically we know that this third angle also would be congruent to this third angle. Therefore, these two triangles are similar. Alright, now again, gave us some crucial information here at the beginning. Line L and line M are parallel. So we know that corresponding angles are going to be congruent. Same with alternate exterior angles and alternate interior angles. Vertical angles are always congruent, and straight angles add up to 180. Alright, so this one does have two similar triangles. We've got this triangle here, and these two angles are congruent because of the corresponding angles of the parallel lines. And then these two angles are also congruent because of the parallel lines. And they share one angle here at the top. So really what we end up with is a smaller triangle here. And then again, if we just ignore that line in the middle, then we also have this big triangle here. And yes, they do share that purple angle there. So that's about how it would look. Something like this. Just if we were looking to color code this thing, okay? So there are two similar triangles because all three angles are congruent that are corresponding. All right, you guys, that's it for this lesson. Go and have the teacher, the substitute rather, pass out the homework for you. If you guys need to, I'm going to put this lesson on Canvas once I get back so you guys can watch it over and over and enjoy it for the rest of your lives. So yes, it will be on my YouTube channel. So good luck with that, you guys. We will see you next time. Good luck.